Okay, the first one is just differentiate. So you differentiate it normally. Y dash equal differentiation of 1 is 0, differentiation of 1 over x is negative 1 over x squared, plus differentiation of the sign is cosine x. Next questions, find the coordinate with the gradient of the tangent. The moment you read the gradient of the tangent and you are doing a differential equation paper, so you will have to differentiate 1 over x plus 3. This is the gradient, so you make it equal to 4. Rearrange, you'll end up with x equal to 1. Next, you find the coordinate. So that's the x value. You find the y value by substituting the x in the main equation. Ln 1 is 0, so y is equal to 3. So the point is 1, 3. Okay. Next question is the curve is defined by parametrically, so you will have to differentiate dy over dx. You need to differentiate the y with respect to t first, so using the chain rule, and the x with respect to t is 2, so dy over dx is this one divided by that, so 2 divided by 2 is 1, so that's why you end up with sine t cosine t. Now they find the equation of the tangent, so this is the gradient. Let's find the value of the gradient by substituting pi over 4. Let's give you a value of half. Now finding the y value by substituting pi over 4 in the y equation, and let's give you a value of half as well. And now the x by substituting pi over 4 in the x equation, and that's where you end up with pi over 2. Now find the equation is y minus half equal half, open a bracket, x minus pi over 2. You can leave it up to this stage, or you can further simplify or expand, it doesn't matter, but you can leave it in here because that's the equation. The next one is find the x values where this is increasing. So the first step is you will differentiate, that give you ln x plus 1, make it equal to 0, so that give you x equal e to the power of negative 1. Now I will double differentiate, find is a maximum or a minimum, and then I will find the double differentiate value for this, and that's giving me e, which is greater than 0, which means x equal e negative 1 is a minimum. Because it's a minimum point, so anything beyond that point will be increasing. So the function is increasing, so fx is increasing for x is more than e to the power of negative 1. Now next questions is you've got a triangle inside a curve, so I'll go straight away with these type of questions. I'll go straight away and see what's the requirement. So we find the maximum area, so that's mean this is the function that you will differentiate, and because of this function has two variables, so we'll have to rewrite them all using one variable. Now we'll come to the height of the triangle. Now this bit here is the y value when x is substituted, so this is x, and that y value is x minus 2 all square, so that's mean so that's mean the height of the triangle is 4 minus this y value. Now the base of the triangle is, if you see, that's 2, so the half of the base, so half of the base of the triangle, it's 2 minus x. So that's mean the area, it's 2 minus x multiplied by x minus 2 all square. Sorry, I've got that negative 4. Just delete that. Sorry, times 4 minus x minus 2 all square. Now when you rearrange, simplify, you will end up with 8x minus 6x squared plus x to the power of 3. Now I'll start differentiating, is 8 minus 12x plus 3x squared. Now make it equal to 0. You will end up with two values of x is 3.16 and x equals 0.85. Now we need to find which one of those values give me the maximum area. So I will double differentiate. And now I will substitute, just continue on this side here. So I will substitute the 3.16 into the double differentiating function, and that give me 6.96, and that's greater than 0. So 3.16 is a minimum. So that's not the one that I want. That means the other one is a maximum. You can also check it if you want, and that's giving me 6.9, negative 6.96, which is less than 0. So 0.85 is a max. Now finding the maximum area, I'll just substitute in the main equation. And that give me the area is 3.08. That's the maximum area. Now next question is answering those type of, analyzing a function equation, a function graph. So the first one, it says find the x values for fx is not continuous. So not continuous is this bit here. Can you see that's ring or the empty circle? So when x is equal to 0. The next one is not differentiable. We said it's not differentiable where it's a sharp ends, and when it's starting where it's ending. Okay, so the sharp ends when x equal to -5. So that's the first one. And the other one, can you see the curve is ending on the same x value, it's starting another curve, so it's discontinuous in here, which is x equal to 0. The next one, f dash to x is 0, obviously when you have a turning point, and the turning point as x equal to -2. F double dash is less than 0. F double dash is less than 0 when the function is decreasing, and you can see it's decreasing up here, so that's mean when x is greater than 0, less than 3. Now next questions, you've got double coins in here, and as I said, with these type of questions, the first thing you would do is just go and read what's requirement. So I'll go right at the end of the function. It says find the rate of the fluid is taking out, so that's the requirement of dv over dt. Now I will write the differentiated equations. So it's dv over, I need to see the volume of the cone is 1/3 pi r square times h. That's the formula for the volume of the cone. So I need to see is, am I going to differentiate the v with respect to r or h? So I need to go back to the question and see which one is being given, which rate is being given. So you can see the rate of the height is being given. That's why I will differentiate with respect to h. Now because is the volume here, the volume formula, it's has r and h, so I need to rewrite it in terms of h only because I'm differentiating with respect to h. If I go back into the equation, you can see there is two triangles. That's 100, that's the radius of this bigger cone, and the height of the bigger cone is 300. Now this is the radius of the smaller cone. So this is a similar triangle because they're sharing an angle in here, and both those angles are 90 degrees, so definitely those two are equal as well. So using the similar triangles rule, which is the ratio of the length of their sides are equal, which means 100 over 300 is equal radius of h. Rearrange, you will end up h equal 3r, so r is equal h over 3. Now substitute that back into the volume equation. I get pi r to the power of, h to the power of 3, because it's h squared and times this h, so it's h to the power of 3 over 3, and 3 squared is 9, so it's over 27. This is the one now I can differentiate. So dv over dt equal, differentiating dv at dv over dh. I'll differentiate it on the side here, and that's given me 3 pi h squared over 27. Simplify it further, you will end up with pi h squared over 9. Now substitute that in here. Now the h is being given in here, which is 100, so it's 100 squared over 9 times dh over dt is being given, which is 10. Substitute, using the calculators, you will find the answer of 34,907 centimeter cube per hour, and just using the units being given. Now the next question is a triangle that has three sides. A is on this curve, so the y value of the A is this, and B is directly below A, and then you've got the C in here at 90. Okay, now this one here is the x value. They want to find the maximum, gives an area of a maximum volume, so they want to find the maximum, what's the value of x, give the area of a maximum ABC. So the area of a triangle is half base times height. So the height of the triangle is, just because this is start at 0, so the height of the triangle is 9 square root of x, because that's the y value of the A. So 9 square root of x. The B of the triangle is 9 minus x, and times half. Simplify this further. And keep simplifying. I haven't differentiated anything yet. I'm just trying to simplify everything. So it's 40.5 square root of x minus 4.5 x square root of x. Now I start differentiating, end up with 20.25 over square root of x minus 4.5 square root of x, just the product rules, 2.25x over square root of x. Now simplifying that, that will simplify with this one here, so left is square root of x. This one and that one will be like terms because both of them got square root of x, so that's why I'm going to rewrite this as 20.25 over square root of x minus 6.75 square root of x. Now make it equal to 0, so you will have 20.25 over square root of x equals 6.75 square root of x. Cross multiply, you'll end up with 20.25 equals 6.75x. So x is equal to 3. Now we'll have to double differentiate. So double differentiate this one, this equation here, you will have as negative 10.125 over x to the power of 3 over 2 minus 6.75 half that. I'll just 6.75 over 2 square root of x. And then if you substitute the 3 in this equation, you will end up negative 3.9 less than 0. So x equal to 3 is a max. And that's what's required. So find the values of x, max, and you proved it. Now next questions, find the derivative. So it's a quotient rule. So g dash to x equal sine x minus x cosine x over sine square x. So it's quite straightforward. Now next questions, you've got the ln x. So the question says find the equation of the tangent. So you will have to differentiate, find the gradient. So substitute x is e, so the gradient is 1 over e. Now the gradient you've got the x value. Now we need to find the y value. So it's ln e, which is 1. So y minus 1 equal 1 over e x minus e. You don't have to rearrange, you can leave it here or you can rearrange and you'll end up with this. So it's up to you. Next step, as the curve is defined by these functions here, find the coordinate of the stationary point. So basically you will have to differentiate because of the stationary point. So I'll differentiate using the product rules. Make it equal to 0, and that will give me x is the common factor, 2 plus x equals 0. So under two values is either x equal to 0 or x equal to negative 2. Now substituting this each value into the main equation here, you will end up with y is equal to 0 or y equal 4e to the power of negative 2, which is you can find the value for that if you want. So the two coordinate is either this or the other one is negative 2, 0.54. Now next questions, you find the values of this is decreasing, so you will differentiate first, and when you differentiate using the quotient rules will be x over ln square x, and because it has a negative gradient, so that's mean for the values that this function is defining you only have a negative gradient, so will be decreasing. So negative gradients mean it's decreasing, the function is decreasing. Now if you draw this function, you will see the function is defined. So fx is defined between x greater than 0, so less than 1, and also x greater than 1. And because it's positive numbers and the gradient of the function is negative, so which means as the gradient is negative, so fx is decreasing for that values. Now the next question is another parametric equation. So I will find the dy over dt first, which is 3 tan square t 6 square t, and the dx over dt is equal 3 cosine, because it's -3 minus 1, so it's get begin -4t multiplied by the coefficient, the differentiation of the cosine, which is negative sign, so that becomes positive sine t. Now dy over dx is equal just that one divided by that. So we'll have that 3, because it's sine and cosine, so I'll rewrite that in terms of sine and cosine as well, just to try to simplify. So that will give me 3. Instead of the tan, I'll write sine square t over cosine square t times, instead of the sec, I'll write 1 over cosine square t divide by 3 cosine -4t sine t. Now if you try to simplify, so I will have 3 sine square t over cosine square t, and so it will be divided by that, so I will change the division into multiplications, and that will give me, that's to the power of 4 times 1 over 3 cosine, not -4, so I'll write -4t sine t. Now that one with this one simplify, because when you multiply you add powers, so that gives me 0. This sign with the one of the signs will simplify, and the 3 will simplify. So the final answer, dy over dx, is equal sine t. So now they say the equation of the tangent, so I'll just substitute y minus instead of the point of the y, I'll write this sine t x minus cosine -3t. Now rearrange y equal, because of the equations y equal, and sine t times, so that's x sine t, that's the first part is required, the other part is tan x, so I will just expand first and I will show you how to. So we'll give you sine t times cosine -3t, and changing that to the other side become positive tan 3t. Now because it's the answer here, I need to have tan. I've got this term, but the other term is tan by itself, so I need to have tan as a common factor. And to have tan as a common factor, sine over cosine is tan. So I will rewrite this, just change it in here, continue on this side. X sine t is the same, minus, I will rewrite the sine over one of those cosines to be tan t. The other square of the cosine, so it will be 1 over cosine square, is sec square t plus tan 3t. Now y equal x sine t. I need to get negative tan as a common factor. The reason is because of this term here. What's left is sec square t minus tan square t. Now sec square t minus tan square t is equal to 1. It's one of the identities. So y equal x sine t minus tan t, and that's proven.